In this example, notice it looks a little bit different than the last few. Notice that we actually have expressions here instead of just a value, right? Before we just had a single number, but now we got some variables thrown into the mix. We're still going to follow the same process and still keep with that same idea that this mid-segment right here is going to be 1/2 of this segment of the triangle on the side over here. In other words, I could write this out as DE. So segment DE is going to be equal to BA divided by 2. So just keep that in mind. Now we're going to go ahead and we're going to start writing this out. And I'm going to write it out just like this, but instead of putting DE and BA respectively, and I'm going to highlight them, DB and BA, I'm actually going to put the expression in its place. So for DE, I'm going to go and put the 2x minus 3. So 2x minus 3. And I'm going to set this equal to BA, which is x plus 9, divided by 2. Now, once we get here, we're going to follow the same process you saw in that first video. It just looks a little bit more complex, but I want to get rid of this denominator of 2. Now, notice that x plus 9 is being divided by 2. So to get rid of it, we want to do the opposite of dividing by 2, which is multiplying by 2. And if I multiply the right side of the equation by 2, I have to keep it balanced and multiply the right side of the equation. the left side of the equation by 2. Now on the right side, remember anytime you multiply a fraction by its denominator, they just cancel. So we can just cross them out. And on the right side, this simply becomes x plus 9. And on the left side, we have to multiply this 2 to this entire expression. So what I'm going to do is, I'm actually going to draw parentheses around it, because that helps me not forget to multiply this to both terms on the inside. For instance, I'm going to take this 2, and I'm going to multiply it to 2x. So if I were to write this out, right, this would be 2 times 2x, which if I multiply that together, 2 times 2 is 4, and it really leaves me with 4 x's. And then I'm going to take this 2, and I'm going to multiply it to the second term, negative 3. So I would have 2 times negative 3. And if I were to put that in my calculator, 2 times negative 3 is going to give me a negative 6. Now this just looks like a regular old equation like you saw in 8th grade math, right? It has variables on both sides, and it has a constant value on both sides. So our goal here is, from this point, is we want our variables to be on the left. So I'm going to write the word variable right here. Variables left. And we want our constant value. That's the term that you see that doesn't have a letter, just the number. I want those on the right. Now to do that, I'm going to go ahead and draw a line through the equal sign, just so I can make sure I keep this balanced. And I'm going to move my x to the left first. Now this is a positive x, so I'm going to subtract x. I know to subtract because the original did not have a negative sign. And x minus x leaves me with 0 x's on the right side now. Now to keep it balanced, I must subtract that x from the left side as well. So I have 4x minus 1x, and that leaves me with simply 3 x's. Now I'm going to do the same thing with the constant. I'm going to take this constant of negative 6, and I'm going to move it over to the right. Now here we're subtracting 6, so to move it to the right, I want to do the opposite, which is adding 6. And I'm going to add 6 on the right side as well. Now negative 6 and positive 6 leaves me with 0. So all the constants have been removed, right? They've canceled out. And then 9 plus 6 leaves me with 15. So I'm almost done. I now have 3x on the left, which is my variable, and 15 on the right, which is my constant. I've separated them. And my final step is to get rid of this coefficient of 3. In other words, the number in front of x is called the coefficient, and it's being multiplied to the x right now. That's what it means when you see a number in front of an x. So to get rid of it, and I'm going to circle it real quick, we just got to divide it out. So I'm going to divide by the coefficient of 3 on both sides. And 3 are going to 3 one time, just simply leaving me with 1x. And 3 can go into 15 5 times, leaving me with 5. Now what I've done so far is I have solved for x. It's x equals 5. And notice that's all it asked us to do. It said solve for x. They were not interested in knowing the total length of DE. They just wanted to know what the x was. And that's what we did. My next video will show you how to go ahead and find the length of the line in case they ask for the length of that mid-segment. But in this case, we solved for x. That's what they asked for, and it's x equals 5.